Hi, this is a supplementary math lesson for Algebra 2, lesson 72B, negative angles. This is actually one of the sections we skipped over in our remote learning as we were focusing on other things at the time, and then decided to revisit this as we're focusing on rectangular to polar coordinates, polar to rectangular, and how they deal with vectors. And so I'm going to be working on example 72.2 on page 292 in your textbooks if you want to turn there. So right now we're going to write this polar coordinates 4 at an angle of minus negative 210 in rectangular coordinates, okay? And so we said a polar coordinate represents a distance and an angle from our origin. And we said positive angles are measured counterclockwise from the x-coordinate. So what happens when we have a negative angle? Simply we just go the opposite way. Negative angles are measured clockwise from that. And so what do we have? We have an angle of 210. So we would come around 90 degrees, 180 degrees, and we still have 30 degrees to go. Okay, so our angle is going to be off there where this is 30 degrees to our x-axis, okay, to our horizontal axis. We're going to complete our reference triangle back to the x-axis. And what is our distance out to this point? Our distance is 4. The hypotenuse is 4, okay? So one thing to remember, so this indicates a negative 210 degrees as measured from the x-axis, and yet again our reference angle is 30. And it's not minus 30, it's 30, okay? We could also express that polar coordinate as 4 of an angle of what? It would be 90 plus another 60 to get to there, an angle of 150. Okay, so one thing to note, whether we express this vector or these polar coordinates as 4 at an angle of minus 210 or 4 at an angle of plus 150, they mean the same thing. They are the same exact polar coordinate. They are the same exact vector. Okay, from that point on, the drill is the same. We want to find our right-left coordinate and our up-down coordinate. Okay, so our r is going to be equal to the hypotenuse times the cosine of our reference angle, 30 degrees. Okay, and in the book that equals 3.46. Okay, our up and down coordinate is going to equal the hypotenuse times the sine of our reference angle, the sine of 30 degrees. Okay, and I look at our book quick for that solution, and it is exactly 2. Okay, so then I apply the proper signs. From my origin, I notice my r proceeds to the left, so it's going to be a minus 3.46 r. And from that point on, it proceeds upward, a positive 2.00 u. And let me check my answer book, and that is the answer they have. Okay, so that is our answer in rectangular coordinates. Okay, same drill, just we go the opposite way with negative angles. And just so I'm not throwing here, what am I doing here? The hypotenuse times the cosine. Well, I'm simply applying the fact that the cosine of 30 will equal the ratio of that r side to the hypotenuse of 4. Okay, to solve for r, I multiply by 4 on this side to get rid of it. I multiply by 4 to get rid of it. That was a shortcut method. Look at here. 4, the hypotenuse, times the cosine of 30. 4 times the cosine of 30 gives me the r length. gives me the R length. Okay, so that was a shortcut method I mentioned to you. Once you establish your reference triangle and your reference angle for trigonomic functions, okay, you can do the hypotenuse times the cosine to give you your horizontal length, your R length. You can do the hypotenuse times the sine of the angle to give you your vertical component, your up and down length. Okay, shortcut method. It just keeps us from having to write out the ratio and then rearrange the equation. So if you know by memory, well, when I rearrange the equation, this is what it comes out to be. You can go directly there, and it really shortcuts the method using trigonomic functions. So that's an easy lesson for today. So give a text message, phone call, email if you have any questions. So long for now.